Okay, here's a first and second derivative taken of something with a fractional exponent, like cube root of x is actually x to the 1/3. So here's the basic idea. If you're going to take the derivative of x to the 1/3, that 1/3 power comes out front. This is the power rule times x to the, now instead of 1/3, it'll be 1/3 minus 1. This is the derivative, and we're actually looking at it right here. This is the actual derivative of that function x to the 1/3. The only thing is we'll simplify it a little bit. So for instance, minus 1 will change to minus 3/3, and that allows us to get that it's 1/3 x to the negative 2/3. So that's the start of this. That's the first derivative, just knowing the power rule. Power out front, and then reduce the existing power by 1. And then second derivative, we do the same thing, we do it to the first derivative. So we're going to take the power out front, which makes, we're going to be multiplying by negative 2/3, the power comes out front, times the existing 1/3 that was already there. And then we take that power of negative 2/3 and we subtract 1 from it, which we know is 3/3. And you see that all written there. So it's the power rule again applied to the first derivative. And so little cancel, multiplying negative 2/3 times 1/3 highlighted there is negative 2/9. You just multiply numerator to numerator, denominator to denominator. And that's negative 5/3 now for the exponent. Done. That's the second derivative. So the big key is bring the power up front, multiply them, subtract 1 from it. And I think you got that in that second piece here. I can see that taking place, but somewhere in that first derivative, something else went wrong, made it overcomplicated, I think is the idea. So hope that helps. Email if you have other questions.